What are minor losses in pipe flow analysis? Imagine water flowing smoothly through a pipe, then suddenly hitting a bend or a valve. You might wonder why the pressure drops even when the pipe itself is straight. That's where minor losses come into play. In pipe flow analysis, minor losses are the pressure or head losses caused by components other than the straight pipe sections. These include fittings like elbows, T's, valves, and sudden changes in the pipe size. Unlike the frictional losses along the pipe's length, minor losses happen because these components disturb the flow pattern. When fluid passes through a bend or a valve, its flow direction or speed changes. This causes turbulence and energy dissipation. The fluid's momentum shifts, and some energy is lost as heat or turbulence. This loss reduces the pressure or head of the fluid, which can impact the system's overall performance. To measure these losses, engineers use a number called the loss coefficient, often written as K or KL. This coefficient is specific to each fitting or component and is found through experiments. The head loss from a component can be calculated with the formula. Head loss equals the loss coefficient times the square of the velocity divided by twice the acceleration due to gravity. For example, if the velocity of water in a pipe is 10 meters per second and the loss coefficient for a bend is 0.5, the head loss can be calculated by plugging these numbers into the formula. This helps engineers understand how much energy is lost at each fitting. Even though they are called minor losses, they can add up quickly, especially in systems with many fittings or frequent direction changes. These losses can cause a drop in pressure, reduce flow rates, and make pumps work harder, increasing energy costs. To reduce minor losses, engineers suggest using smoother bends instead of sharp elbows, choosing fittings with lower loss coefficients, and minimizing the number of fittings in the system. Proper maintenance of valves and fittings also helps prevent additional flow disturbances. Understanding minor losses is vital for designing efficient piping systems. By accounting for these losses, engineers can size pipes correctly, select suitable pumps, and ensure the system runs smoothly without wasting energy. In practical terms, paying attention to these small details can make a big difference in system performance. Whether it's a water supply, heating system, or industrial process, knowing how minor losses work helps keep everything running efficiently and reliably.